Okay, so this week's video is going to be a little different. We're going to be doing an AIME problem. It's one of my favorites, just because the AIME is coming up, I think, this Tuesday. So I thought it would be a good idea to just get some warm-up in. So this is going to be the 2017 AIME I Problem 8. It says, two real numbers a and b are chosen independently and uniformly at random from the interval 0 to 75 exclusive. Let O and P be 2 points on the plane with OP equals 200. Let Q and R be on the same side of line OP such that the degree measures of angle POQ and angle POR are A and B respectively, and angle OQP and angle ORP are both right angles. The probability that QR is less than 100 is equal to m divided by n, where m and n are relatively prime positive integers. Find m plus n. Okay, so first let's just draw this diagram out. We have 2 points O and P. Let's just say it like this, and it says OP is 200. Let Q and R be on the same side of line OP such that the degree measures of these two angles are A and B. So we don't know what those 2 points or those two angle measures are, so we can just draw 2 points in. Let's say Q is here, and R is maybe somewhere here. And so we have POQ is A, POR is B, OQP and ORP are right angles. So that means that if we draw this one in and this one in, we have 2 right angles. And why not just fill in this last line here? So the first thing we might notice is that because we have 2 equal angles here, this quadrilateral is going to be cyclic. And not just cyclic, because of Thales' theorem, which basically says that the angle that subtends an arc is going to be half the measure of the arc. If we draw the circle in, OP is going to be a diameter, because half the arc, or half a circle, is 180 degrees, and then half of that is 90. Okay, so this means that 200 is the diameter of the circle, and I'll just say this entire angle is A, and this smaller angle is B. And that means that this angle here is A minus B. Okay. Now that we know that, we know that the radius of the circle is going to be half of 200, so that's going to be 100. And we want to find the probability that QR, which is this length here, is less than 100. So notice that this angle here is A minus B, QOR, and it subtends this arc QR, which is what we want to find, or we want to find the probability that it's less than 100. So if we draw this angle in, connecting into the center of the circle, I'll just call this point C for center. We know that this angle is going to be a central angle, so it's going to be 2 times A minus B, which is 2A minus 2B. And the radius of the circle, which is going to be QC and CR, is 100. So what does that tell us about this length QR? Well, QR is equal to 100 when this triangle is equilateral, which is when 2a minus 2b is 60. So I'll just write that down here. QR equals 100 when 2a minus 2b equals 60. And for all 2a minus 2b, when it's less than 60, QR is going to be less than 100. Because you can just kind of imagine this angle is closing in, and QR is going to get closer to each other, and that's going to make QR smaller. So QR is less than 100 when 2a minus 2b is less than 60. And notice that we actually made an assumption here. A is not necessarily greater than B. We could also have B is greater than A, so I'll just write that down here. We would have something like this, where this entire angle is B. This would be A, and this would be B minus A instead. So it's not actually just 2A minus 2B. It would actually be this absolute value. So in other words, we can also have 2b minus 2a is less than 60. So now we just have two cases to consider, and this simplifies the problem because now it's just a simple geometric probability question. So we want to find the probability that either 2a minus 2b is less than 60 or 2b minus 2a is less than 60. This is just a minus b is less than 30, and b minus a is less than 30. And we can actually replace both of these variables with x and y to make things easier. So first, notice that a and b are chosen from 0 to 75. So let's just draw this diagram here. So let's say this one is I'll just replace it with x and y to make things simpler. So let's say a equals x and b equals y. This will be the x-axis, the y-axis, 0, 75, 75. So in this case, we have y is less than 30 plus x. So that would be basically this length here. This is 30, and we want everything under this line, so it would be like this area here. And the other case is x minus y is less than 30, which means we would have a line like this, and everything above this line, so that's just going to be this angle here. So all that's left for us to find is the area of this region divided by the entire area, which is 75 squared. So let's just write the denominator as 75 squared. The area of this interior region is just going to be the area of 75 squared minus these two triangles. So this will be 45, 45, and that will be 45 squared, or 45 times 45 divided by 2, but then we have two triangles, so it's just going to be 45 squared. And then we can just simplify this. So let's say we divide the top and bottom by 15 squared. We get 5 squared minus 3 squared over 5 squared, which is equal to 25 minus 9 is 16. 5 squared is 25, so 16 over 25 is m over n. Find m plus n, so that's going to be 16 plus 25. So the answer is 45. Okay, and that finishes the problem. If you enjoyed this AIME problem, just let me know in the comment section. I'll be sure to take your comments as a suggestion.